Hey everybody, Lars here. Time for review video 1 for Unit 3, Big Bad Unit 3. Alright, I'm going to make this a quick one. Because what I used to do is I used to review a little bit about functions, and then I would spend some time at the end of the video and redo that Project Euler program. But what I'm going to do instead this time is I'm going to do the first video, second video, third video, and then I'm going to do a fourth video on doing the Euler, because I'm not just going to do it with functions. I'm also going to do it with libraries. So I'm going to kill two birds with one stone with that particular little piece of code. So because of that, I'm going to wait till the end, and I'm going to do a fourth video this go round. You'll see Unit 3, it's 3 weeks long. Okay? So you're going to have a lot of time. It's more work than the first two, and as you'll see, the final assignment's pretty comprehensive, but you'll get it to go along. Right now, I just want to show you some real quick stuff with functions. And like I said, hopefully we're going to get in and out of here in about 10 minutes. All right? All right, functions. First of all, little hint. We've been using them all along. Let me quick whip up a little list here. I guess I can do that. And I'm just going to print sum. You see right there how it turns purple? It's because it is what's called a built-in function ready for us to go. So now if I just save that and run it, you see I get 30, which is the sum of everything in there. A list is what's called an iterable. And the sum function takes iterables and adds them all up and gives you the answer right up there. You can see idle turned it purple because functions are purple. Hey, guess what? Print is also a function. These are called the built-ins. And if you want to, you can do this. Look at that. I've been watching you guys put quizzes in. It's Monday night. You go to Google and you just say Python docs built-in functions, and hopefully we have some luck here. Hey, look at that, built-in functions, 3.6 even. And as you can see, the list of the built-in functions. We've been using them all along. Look, there's input. We've seen input. There's int that we use for casting, along with also float's going to be in here, and string is going to be in here. Sum we just saw, okay, a bunch of different ones. Do not ever use a val. I don't even know why they keep it in there. All right, so built-in functions are there, and as you can see, they have a name. Sum is the function. They have an argument, in this case a list or an iterable, and they have a return value. Now I printed mine, so that's 30. So you can see the anatomy of a function. So you have built-in functions, and later, when we get to a different part of this unit, you're going to see that we can import libraries and use a whole bunch of functions that are pre-written for us already. But the main point of this video is that I'm going to write my own function, and then we're going to talk a little bit about it. What I usually do, I'm going to start with the def keyword. You see that idle made it orange. Basically stands for definition. I'm going to define a function, and I'm going to call it multicube, and it's going to take 2 arguments. I'm going to do a colon to get a code block. And what I'm going to do is I'm going to say I'm going to create a variable called z, and I'm going to assign it the product of a and b, and then I'm going to return z to the 3rd power. So basically I call it multicube because first I multiply 2 things together and then I cube it. Okay? So now if I print multicube of 2 and 2. 2 times 2 is 4. 4 cubed is 64, so I should print 64. And look at that. Uh-oh, the 30 part's still up there. Let me go highlight and cancel them out. You can see I can use my 3 quotes, or I can use my octothorpes. Okay, so that's multicube 2. Now, you might be saying to yourself, hey, that's great, but why should I bother? And the reason you should bother is this, because now I don't have to change any of the underlying code. I can just change the variables, and boom, I'm there to go. Another thing I can do, if I want, is I can, I can come here and I can do a whole series of different things, and I'm not redoing the code for every single example. I just codified the code I want to use up here, and then I can do it anytime I want. Now, the big thing is this, for I in range, let's grab 1 to 10, 11 being the first thing I don't want, and then let's print, now do I still have it in my, I just got to do 2i, okay, now when I rerun it, bloop, You can see I can run the whole thing. Okay? That's why we use functions. If you remember in the slides when I printed out those stupid lyrics from Detroit Rock City, yeah, if you do it once and then run the function, it's not that big a deal. You didn't save yourself that much time. If you want to run it 20 times, think about it. Put it in a loop. I've written maybe 5 lines of code, and I'm doing 20 different things with it. So it's part of, as you're going to see, a big theme in this particular unit is design. Okay, because we're going to do some different things design-wise that's going to make sense to you. Functions help us to compartmentalize our code. Later, you're going to learn about libraries. Then you're really going to compartmentalize because it's going to be in a completely different file. With programming, you're building systems, and this is going to show you how to build systems. In the second part of the unit, we're going to deal with files. The way we're taking our code and keeping it in programs, with files, you're doing that with your data. So now you're not going to be entering data, get 7, and then running some dopey program. You're going to have real data, and you're going to start reading it in from a file and writing it out to a file. That's part of a system, too. At the end of the day, programming is system building at the end of the day. There's a lot of engineering involved. There's an engineering component to software design. As a matter of fact, we teach a course at Rutgers called Software Engineering, and you learn it's basically software development from an engineering lens. It's actually an interesting course. But what programming does, especially at a higher level, is you're building systems, and you have a series of inputs and a series of outputs, and you have different procedures and things that you do in the middle. So this is the very beginning of starting to see how some of those things happen. One of the big keys in programming is compartmentalization, like when we did the Euler. When we did the Euler problem, it looked like one problem, but it wasn't. It was 3 different problems. So what we did was we broke it down, we solved those 3, and then we came to our solution. All right? Slowly but surely, you're going to see those things get wrought bigger and bigger and bigger. All right. Before I get out of Dodge, there are 2 things you and I are going to talk about. Let me zotch that out and zotch that out. And then we will run a grand finale when we get to the end. All right. I've got my function up there. If you've ever been, exposed to the C programming language before, when you use functions in a program or a file like that, you want the function to be above where you call it, so it's been put in memory already. And real simply, I can just say A equals bad choice. I could say my there equals, not equals assignment. I am dopey and say that all the time, but it's an assignment. 2 is equals or equivalency. 1, how do I get down there, is assignment. I got rid of that. I don't want to get rid of that. And I will say multi-cube 2 and 3. Okay? And then I'm going to print my var. So, yeah, thank you, Idle, for catching my mistakes. I run that, and I get 216 again. Okay, so I'm here, and I'm in pretty good shape. What if I printed Z? What would happen? Now, Z is up here. Z is assigned the product of A and B, so 2 and 3. 2 times 3 is 6, so Z would have 6 in it, and then 6 cubed, 6 by 6, 36, 36 by 6, 216 down there. So Z should be 6. So it should say 216 and then 6, right? There's that pregnant pause again, right? Run. A big old Python error. And if you look down here at the bottom, it says name Z not defined. Not defined. This is something we call scope. When I run this particular function, what happens is Python has this function off in a special little area of memory. When I call it, it grabs a copy and says, okay, let's do this. So I gave it a 2 and a 3. So the 2 is assigned to the A. The 3 is assigned to the B. Then Z is given the product, which is 6. And then Z is cubed, so I get the 216. And then you return the 216 to where it was called. But after you do that, that little area of memory that you ran all that in, everything disappears. It's like a little mini program that gets run, and then it all disappears. Now, this isn't some magical way for me to have you think of it. This is actually what's happening, okay? So when that function gets called, it calls a copy of the function into that little area, and you do all your work, and then you return the variable, and then it all goes away, all right? So when I come down here, and I say print Z, Python doesn't know what the hell Z is because it was in this little mini program, this little function up here, and we're done with it. Okay? If I want to print Z, I can print Z here all day long. Okay? Because when I'm outside here, I'm in an area that us programmers call global space. Okay? In global space, everything can see everything else. But when I'm off here running this little function in this little secret area over here, that's called local space. So when this function is running, you're in local space, and anything you do in local space relevant to all of this stuff is fine. But the minute you do the return and you come back out, you're not running that function anymore. Okay? You're out in global space. So global space does not know what Z is. And as you can see, I will zots that out, and we will run this. And this time it's fine. I get my 6 because I ran it up here in local space. Okay? You have to be weary of that, because if you are out here in global space and you start trying to print things that are in local space and are gone, then you are going to have problems. So be cognizant of the difference between local space and global space. Okay? Now, there's one more thing we're going to do. Let me get rid of that. And let me do that. One more thing we're going to do. We know from above, multi-cube 2,3 is equal to 216. That is great. We print it out. We do that. We can actually use that. You know what? Let me do that. Boop, 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 and get all that stuff back. Now, I run this, and I get 216. What if I just did it like this? Multi-cube 2,3. What's going to happen if I run that code? Bloop. There's no error. Okay? Nothing blew up. My program ran. But you know what the problem is? You did not capture the value that was returned from this function. When we look at functions, we look at some that have return values and some that don't. If something has a return value, it's called a fruitful function. And what we want to do is capture the value. Now, what I always do, maybe not always, but what I try to be a good doobie and do, is capture all of my fruitful functions in a variable. And then I can just print the results of the variable. And I usually do that because if I have it in a variable, then I can later use it in arithmetic, and I can do a bunch of other things with it. Or I can print it multiple times. Boom, boom, boom. You'll see when I do this right here, I get my 216 back. Another thing that we could do if we wanted to is, and I will do it and then put things back, is just print it. Okay? So you can print the variable, and now when I print my var, it'll blow up because it had nothing in it. Boom. My var not defined. See? So if I want this to run properly, I want to do that. Okay? And now I get my 216 back because the return value is in the middle of this print, so it's going to print the return value. So when you have a fruitful function, you have to remember, I want to capture that value, or at the very least print it. But now that I've just printed it, I can't really do anything with it. So what I usually suggest is that you go the capture with a variable way, and then you can print and then use it later to your heart's content. Invalid syntax. Harumph. Yeah, I got an extra thing there I didn't get rid of after the print. Oh, for the love of Christmas, what now? Printing out. How does that not have an ending paren? All right, now we're back in business. Okay? All right, I'm going to take that off. I'm going to take this off. And this is going to be an odd-looking grand finale, but let's run it. Yoo-hoo! All right, there we go. A bunch of numbers. And I'm not going to go through it. But that's the basics of functions, okay? You define a function. The naming conventions for functions are just like regular old variables, okay? Don't start with a number. Don't use any funky symbols. Do not use double underscores. We are going to get to that in a little bit, but double underscores in Python have a special meaning. We call them dunders, and you do not want to be using them. You'll use them later when you know what you're doing. Okay? Remember about scope. All right, and remember about fruitful functions. When they return a value, you want to capture it. Yeah, you could just print it in some cases, but in a lot of cases, you want to capture it in a variable so you can use that variable and do things later. All right, great. Announcements, not going to do a lot because in a couple of days, you're going to get another video. I'm assuming Unit 3 started Tuesday. I'm assuming I gave you this video Thursday. I'm assuming you'll get the second video over the weekend. All right. Tomorrow, when I start up Unit 3, I'm going to give you your... See, you're going to have all this stuff already, so this is going to be just, I'm preaching to the choir already. Tomorrow night, I'm releasing all the stuff for your midterm assignment. So you're going to have all of that stuff. Hopefully soon you'll be getting grades, because I told the TAs I want to front load grades this particular unit, so you know where you stand and you can concentrate on doing well on Unit 3. I will give you this warning because I give it every semester and it doesn't seem to matter, but I'll give it again. I know I sound like a parent. I sound like a broken record. You cannot procrastinate with Unit 3. If you pick up Unit 3 3 days before the unit is due, you're not going to get it done. Just the bottom line. And I've had people cry, can I have extra time? I can't do this, blah, blah, blah. And it's just not going to matter. All right? I'm nasty when it comes to that stuff. This is grad school. You got to read requirements. You got to get it done. That's how if things break down, then nothing gets done. All right? So that's why you have to meet deadlines. All right? It's the show now. It's not silly, stupid little undergrad anymore. All right? So I beg you, engage with the resources early for Unit 3. And once you wrap your head around that, I will give you the assignment early too. I'll usually give you the assignment with a cool 10 days to do it, maybe even more than that. Okay? No promises, but maybe even more than that, depending how quickly I get you the resources. Because you're going to have slides, you're going to have Zell, and then you're going to have 3 videos. But then you should watch that 4th video too, because that is usually a synthesis video, and it wraps everything up. I know this unit, a couple of little inside baseball things. When I put those little extra credit things in the slides, I don't give a rat's ass about you getting an extra point. That tells me when you're reading, okay? So when I have a lot of people asking for extra credit with 2 days left in the unit, I know you're procrastinating, all right? Then I can make judgments based on that. I know for a fact a lot of you are procrastinating because a lot of you are asked for that extra point in the last couple of days, all right? So that's why I do that, all right? So I also can look at YouTube and see how many people have watched the videos. And if I have 37 people in a class, and on the last day of the unit, I look at the 3rd video and see only 26 people have looked at it, that tells me something, all right? It tells me, people are trying to cut corners. You cut corners, you're going to end up getting a B. Just telling you. I don't care how smart you are. I don't care how much programming experience you have. I know I built the course a certain way. Got to apply yourself. Got to do the right thing. Repetition is beneficial, all right? Engage with the resources early. I know I already sound like a broken record. I already hate myself for sounding like this. I sound like my damn parents. But engage with the resources early. That way you can just wrap it up early and relax, okay? Or, God forbid, get an early start on your midterm, all right? That's not going to be due until March 11th, I think. So you have a full month. I'm shooting this on the 12th. You're going to get it tomorrow. You'll have a full month, and you'll get it out of the way before spring break. Because I build spring break into Unit 4. And I'm not working that week, so I don't expect you to work that week either. So no worries about it. But you'll have the midterm already out of the way. So you'll actually be able to relax. It'll be no great shakes, all right? All right, I already blabbed on enough. You be good. Keep doing what you're doing. Next couple days, the 2nd review video will come out. It's on files. And then a couple days after that, I'll get you the 3rd video. Then you relax a little bit. I'll get you the assignments. And then I'll get you that 4th video where we're going to use all of our new tools and rewrite the Euler 6 program, all right? And then, Unit 1, Unit 2, Unit 3, you're going to have the basics of Python. Then we're going to start, doing a little bit of spackling and filling in gaps. We're going to learn about computer science, sorting and searching and recursion and the analysis of algorithms. Then we're going to learn about object orientation and a slightly different way to write your programs, all right? So we'll get there, and you're doing fine, so don't worry about it, all right? Then I'm getting out of here. You be good. I'll talk to you later. Bye.